Hi everyone, it's Kyle, and today we're going to be doing another oxidation reduction balancing notes. So go ahead and pull out a sheet of binder paper, and as you're doing that, just a quick reminder that remember chemistry is more than just math and more than just equation. It's, check it out, a pair of glasses, a lens to approach life. Over here in the background, you can also see that I added a periodic table, so you'll be able to see like, oh, here, H is +1, or oxygen here, 2-, as we do our oxidation reduction practice for today. So again, get a piece of paper out, and let's get started. So the first thing we're going to do is we're going to be understanding what the whole point of a reduction oxidation reaction is. And actually, if you're looking at this through a computer, you probably know you're actually using a redox reaction because your computer has a battery. And so let's go ahead and let's start off first by drawing this little beaker thing. And this beaker thing is going to have two things. It's going to have two pieces of metal in it, Li and Na. The most common type of battery is actually called a lithium ion battery. It's commonly used in robotics and a bunch of other things. So when we have this is actually in the solution. That's why you'll see a lot of things are actually as ions. And this metal actually goes above there. We can actually see that there's two reactions happening. There's the Li solid, which is this piece of metal right here, which turns into Li plus, aqueous, and an electron. So I'm going to draw Li plus right here, and an electron. Now this is, again, a galvanic cell, and we haven't actually covered this, and this is actually not the complete design, but this is just to get your idea of redox reaction going. There's actually a salt bridge and a bunch of other wire connecting things later, but that's not the focus. The focus right now is to understand what is a redox reaction. Now we also have another thing, which is Na. So look at, Li solid is losing its solid, and it's losing its electron. Now if something has to be lost, remember, you can't just have free energy. You can't just have free electrons floating around. It has to come, and there needs to be a balance. So that's why Na is actually going to be forming from Na plus and an electron as well. Remember to put your phase notation as well. So we do have Na plus, and we do also have an electron as well. So check it out. We're losing lithium, losing an electron from lithium, and we're gaining an electron for sodium. So which one is going to be which? Well, check it out. We have this thing right here. OIL RIG. And that stands for oxidation is loss of electrons. Reduction is gain of electrons. And so you can see here, in this specific example, lithium is losing an electron. So what is it going to be? Oxidation. Na, it's going to be gaining electron, so it's going to be reduced. Great. So now that we have this, let's take this oil rig, let's take this over here, and let's put it into an actual equation. Great. And so the question that we have specifically for this this notes is a question from Chapter 20, page 90. Chapter 4 homework. It's also for the electron, for the solution strike, number 26A. So what we're going to have is we'll have H plus aqueous. You're going to have to leave a little bit of space for this. Plus NO2 minus aqueous plus CrO72 minus, 2, and this is dichromate, yields Cr3 plus, aqueous, this is a chromate ion, plus NO3 minus, aqueous, plus H2O liquid, which is just water, and that's nitrate. So remember that the first step is to find oxidation numbers. Remember the 4 steps. Find oxidation numbers, identify the oxidation or reduction using oil rig, find the balanced molecules, and then balance the rest of the equation with charges. So we're going to start with step 1, find the oxidation numbers. Now if you already did this in class, you should be able to do this, and so pause the video now, go ahead, find the oxidations of all the numbers. Ready? Let's review. We know that this H plus over here needs to equal, whole thing needs to equal +1. So H is going to have an oxidation number of +1. Simple as that. What about O2? Well, this whole thing is going to be equal to minus 1. And so we're going to have minus 2 over here. That's 4. Minus 4. And so this needs to be plus 3 over here. Again, I'm just going to erase this because you don't actually do this step written out on paper. That's just a mental step. Step minus 4 plus 3, negative 1. Same thing for here, minus 2. Minus 2 minus 14. We need a 2 minus, so we actually need a plus 12 from here. There's 2 of them, so we do plus 6. 12 minus 14 equals negative 2. We're good. This whole thing needs to be plus 3. Minus 2, 6, 6 plus 5. This whole thing, minus 2, plus 1. H2O is a common one. You can just memorize that. Now, let's use our awesome oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. To figure out which one is being oxidized, which atom is being reduced. Only one atom is going to be oxidized. Only one atom is going to be reduced. So, let's check it out. H and H plus, that's all plus 1. We're good. We know that that doesn't change. How about N? Oh, plus 3 to plus 5. Well, that's a change. I'm going to draw an arrow right here, pointing from the reactants to the products. Remember, in chemistry, it's always going to be final minus initial. And we're going to use a handy-dandy formula, as noted in Mr. Lee's help sheet. Subscripts. And this is our coefficients right here. Coefficients is what we're actually solving for right now. Subscripts is the mole of each atom in each equation. So in this case, we're going to have final minus initial, which is 5 minus 3. And the subscript is going to be 1 because it's N1, O2, and 1, O3. The coefficients we don't know yet. Again, all of these, you don't need to write out coefficients F minus subscripts, but you can if you are learning this in the beginning. Let's go to the next one, O2 minus. Okay, O2 minus is going to be the same, 2 minus on both sides. Oh, but look at CR. CR is changing again. Let's draw an arrow over here. Final minus initial, negative 3. And we have how many moles? We have 2 moles, 2 subscripts. So that means CR2, there needs to be a 2, C2 CR3 plus right here. Now, note that when we do put the 2 here, we're just putting it temporarily because, for example, if this is 3, then this needs to become 6. But that's just there to remind us for the time being. 2 moles, 2 moles. Now, let's figure out what is going to be the least common multiple between these guys. So we have 2 and 1, 6. So this one will stay as 1, this one will stay as 3. That way we have 3, so 6 on this side, 6 on the other side. Now let's determine what is the oil rig. Remember that this one is a positive 2. It's becoming more positive. More positive means you're getting rid of the negative. And in this case, negative is going to be what? It's going to be an electron. So you're gaining electrons or losing electrons if you're becoming more positive. More positive, losing the negative, losing the electron, oxidation. Ox, right here. Do the same thing, pause the video, for the next one, which is CR. Ready? Okay. We have minus 3 becoming more negative. You're gaining more negative. You're gaining more electrons. You become red, reducing. So there you go. CR is being reduced. N is being oxidized. It might ask you, what is the agent? The reducing agent is going to be N. And the oxidation agent is going to be CR. You just switch them. Think of a secret agent. The agents are always working for the other side. But that's just a slight technicality for like what the definition is. But I'll write it out right here. N is reduced. N is oxidation agent, or reagent as they call it. Oxygen is... Oh, sorry. My bad. N is... Sorry about that. N is oxidized. That's why it's really important we draw that right there. N is reducing agent. It's the thing that lets us reduce. O is reduced, red. O is the oxidation agent. It's what allows N to be oxidized. Great. Let's go into our next step. So remember, we have identified the oil rig, and we did balance the molecules. Oh, no, sorry, we haven't balanced the molecules yet. And so what we need to do is, okay, balance the molecules. Check it out. We have 3 over here. 3 and 3 times 1 times 1 times 2, 1 is still at 2, so we're good. Now that we have this, we need to make sure, step 4, the charges all balance up. Remember that when we gain and we lose, they have to be even. There's no such thing as free energy. So that means the charges on the left, or reactants, needs to equal the charges in the product. You might also see people denote it as this: charge reactant equals charge on the product side. You'll be seeing a lot of this in thermodynamics. So what we're going to do is we're going to add up all the charges on this side. We do have a +1 on this side because of the H+. Oops, that +1 on this side because of this H+ right here. NO2- has a minus, and we have 3 moles of that, so that's going to be -3. 2- for chromium, so we're going to have -2, and the coefficient is 1. And that somehow needs to be equal to this one. 3 plus times 2, which is 6. NO3-, which is -3 because we have 3 moles. And then we have H2O, which is 0. So we can see that this doesn't really add up. We have -4 on this side. We have 3 on this side. And we need to change either the left side or the right side. In this case, we are having the H+ on this side and H2 on this side. Cr, N are all set in stone. We already did all these beautiful steps over here to get those to be balanced. What that means is you can't touch them. The only thing you can touch is the H+ and the H2O. H2O is 0. No matter how much H2O you have, you're not going to affect the charges. What you can affect the charge is using H+. So, stop the video. How many moles of H+ should you have so that you can balance out this to have 3 equals 3. That is our goal. Pause the video, go ahead. So, if you said, well, we need 3 more moles of H, you're right. So 3 more moles of H, it's already at 1 right now, so we actually need a +4, -3, -2. Equals, oh sorry, not a +4, that's not right. We need +5, 8, 3, because this side hasn't changed, so we can just bring down to 3. But it's, again, same as +6 -3, 0. Just bring down to 3. And so let's look at this. +8 -3 -2, does that check out? Well, yeah, it does. That is actually completely right. 8 -3 is 5, 5 -2 is 3. Boom, checks out. In order for us to have +8 on this side, well, we need to have 8 moles of H+. Let's go ahead and do one last check, balancing the equation with charges. Remember, you have to balance the whole equation. 8H+ needs to make sure that there's 8 moles of H on this side. Well, in order to balance this out, well, we need 4 moles of H2O. It's 8 and 8. Let's check out N, 3 on the left, 3 on the right. We're good. Oxygen will skip into the N. Cr is 2. Cr is 2 on the left and right. Now O, we have 6 over here. And we have 7 over here. We have 9 over here. And we have 4 over here. 9 plus 4 is 13. 6 plus 7 is 13. Beautiful. All of the oxygen, all the hydrogen, everything is balanced. So here we go. We have this awesome equation here. There's actually one more step that we need to do. We need to rewrite this and make it nice and clean. 8H+ aqueous plus 3 NO2- aqueous, and again that's nitrite, plus dichromate ion 2- aqueous yields 2 Cr3+, Cr3+ aqueous plus 3 NO3- aqueous plus 4 H2O liquid. Box your answer and pat yourself on the back because that was awesome. So we went through all 4 of these steps, understanding that we need to find the oxidation numbers to balance out the oxidation and the reduced atom. We can write out this awesome statement right here to understand what is happening in the equation, and also this ox and this red right here to find the coefficients. We balance using the molecules, and then we balance using charges, and then make sure that all the atoms match up at the end. Afterwards, we box the answer, and voila, we're done. So, congratulations. Thanks so much for listening. Again, we'll be posting more lectures hopefully in the future, and we look forward to meeting you guys in class. Thank you so much for being super awesome, even through these super unprecedented times with, a whole teacher situation. We really appreciate you guys still working really hard and paying attention during lectures. We hope this helps, and we'll see you guys all next time.